helicopter problems are like several other kinds of things, like you catch a fish and you pull the fish out of the water. It is about tension under dynamic circumstances. So that's what these kind of problems tend to be about. So they're elevators, or they're helicopters, or they're you pulling something out or pulling something up. These are the kinds of problems that they are. I want you guys to become accustomed to them. They're not particularly hard, but students tend to have a bit of a struggle the first time they do them. So I want you to think of the three cases I just described. There's the first case where it accelerates upwards. There's the second case, I'll put then, constant velocity. And then it slows to a stop, so it accelerates downwards. I'm assuming you know that to accelerate upwards, you have to have an upwards acceleration to pick up speed. And then if you're moving upwards and you want to stop, that your acceleration has to be downwards. I'm assuming you know that because we've talked about it already. But some of you probably are concerned or confused as to why the acceleration is downwards when you're trying to slow down. I'm going to have to hope that those people have dropped the class by now. But we'll say downwards acceleration of 3 meters per second squared. Upwards acceleration of 2 meters per second squared. And it was cruising at 10 meters per second going upwards. All right? Here's what I want you to tell me. I would like you to tell me the tension in the cable for all three stages. I want to see if you can do this. What is the tension in the cable for all three stages? In fact, let's just do one stage. Do the tension in the cable for this stage, for the helicopter accelerating. If you think you have the right answer, great. Share it with your friends. There are whiteboards on the table. By the way, first period, only one person had a board that had the wrong answer. First period beat you on this little contest, like by a lot.
Did anyone have it right?
Yes. There was a right answer displayed on a board or two, or maybe one. It was definitely not displayed on your paper. Did you draw a free body diagram?
Yes.
Okay, now, again, you're going to hate this. I say it all the time, free body diagram. But that's there for you in case you don't know how to solve the problem. If you know how to solve the problem, you don't have to draw a free body diagram. I don't always have to now. I have enough mental space. I can hold a picture of a couple of arrows in there. But it's there for you to kind of figure out how things are lining up. So I'm going to start by drawing the obvious stuff, and that's going to be a downwards arrow indicating the weight, which is 2,500 newtons. The only way the box accelerates upwards is if the forces acting on the box are unbalanced upwards. So I'm expecting that you have another arrow longer than the first that is pointed upwards. That is tension, an unknown force.
Oh, I thought we were doing the
Now, we don't know the mass of the helicopter, so it's the box. Now, this is a Newton's second law problem, and if you're actually taking notes and you want to know things, there's something that you might want to write down here. The net force on the helicopter is the net force on the box is the mass of the box times its acceleration. So the net force on the box was 500 newtons. So if you're asked what is the net force on an object, that's all you do. So be careful. Throwing the word net into a problem can change what they're asking about. But the other side of this, the net force is the sum of the forces acting on the box, which is tension and weight. Oops, one extra zero. So if I want the tension, looks like it's 3,000 newtons. So yeah, there's the right answer out there. There's a couple of them. The consensus, actually. But we also had 7,500, and we had 2,000, so we had lots of options to choose from, but some right answers. Only 500 off, yeah. So maybe practice real quick. These should be obvious. I don't think you have to do this one. But I want to remind you, if it's a constant velocity, net force is 0, right? So the tension is 2,500.
Yeah.
Some of you will put 0 or will choose 0 on the next multiple choice test. But it's not. The net force is 0, but the tension has to be at least the same as the weight. But do the other one. See if you can get the other answer. And put it on the whiteboard. I'd like to see if maybe we have an improvement in consensus. If you want the box to slow down and it's moving upwards, then the unbalanced force has to be downwards, right? You're going to have to explain yourself on the next test, and your explanations are going to have to get better because I've been reading a lot of the tests from last time, and a lot of you are just basically talking in tongues or gibberish. It's not particularly good. So simple words work better. The helicopter is moving upwards, and you wish for it to slow down to a stop. The unbalanced force has to be in the direction of the acceleration, and that has to be downwards. But there still has to be tension upwards. It wouldn't be negative, right? The weight's still 2,500. We just want less tension upwards. Okay.